Welcome to question 2. We solve it just like we solved question 1. Please watch the video for how we did question 1 as we get to be a little into the tutorial. We'll start skipping some steps. So now here in question 1 part 2, what we see is we've been given again the same. Actually, we've been given the 53 degrees originating from the negative part of the x-axis, and we've been given the 42 degrees, which is actually forming the component of the f prime. So with this, let's go without further ado. Let's start. Okay, so again we are going to find our f prime. So our f prime is this one, which is here. Okay, f prime in the middle there. F prime, that line which is running diagonal there. So we need to find that, and we have the 42 degrees. Obviously we know that we'll be able to get it very easily. So then we go to our where we know that f prime is equal to f cos 42 degrees, and this will be equal to this will be I need to read cos 42 okay times 750. Okay, so we have 557.36. This is pounds again. Okay, 36 pounds. Let me say no need to convert to newtons. I know we are used to newtons, but no need to convert to newtons. Pound, the US customary units are also acceptable in our country, so we can just use them like that. Okay, because f prime is in space, you cannot really put say negative or positive. Just leave it like that for now. Okay, and then we can find fz, okay, which in this case will be negative even, because I see the z component by observation. I'm able to see has a negative component there, so it will be f sine 42 degrees, which is 750 times sine 42 degrees. This will be equal to it's moving in the middle. I thought it is at the edge. So this will be equal to sine 42 times 750. Okay, this is equal to 501.85 pounds. Okay, now we need to use f prime to find fx and fy, and with that 53 degrees it's not a problem. So we'll just say fx is equal to, it is a negative component, so we shouldn't really worry about that, so we'll just insert the negative there. So we'll say negative f prime multiplied by, now what we have is the 53 degrees there, so it will be the cos of the 53 degrees. So this is what will be negative 557.36 times cos 53, and this will be equal to, let me just which is negative 335.43 pounds. Our Fy is equal to, of course the component is positive as we can see, and it is equal to it's equal to f prime sine 53 degrees, which is equal to 557.36 times sine 53 degrees. This will be equal to, this will be equal to 445.13, okay, pounds. Okay, that being done as the answers for part A, we have one answer, this one for Z, and for fx the answer is this one, and for fy the answer is this one. So answering part B now, we are saying B, expressing in the Cartesian vector form the force, we'll have minus 3, oh, for fz, sorry, it is actually negative there, don't forget, because z has a negative component. Minus 335 minus 335.43 I, and then I have plus 445.13 J minus 501.85 K, and then in brackets pounds at the end like that. Then we say F as a vector is equal to that. That's your answer for expressing in Cartesian vector form. Finding the angles as we were told. So our alpha is equal to cos inverse of that one, which would be cos inverse of minus 335.43 over 1000, which is equal to not not over 1000 over 750. What's my problem now? Okay, over 750. That's the magnitude of this force. So we have minus 335.9.43 divided by 750. That's the force. So this is coming to 116.57 degrees. Okay. Beta is equal to cos inverse of what we had here, which is 445. Yeah, this is 445.13 over 750, which is equal to, if you actually do your calculation, 445.13 degrees. Okay. Wow. Sorry, I think I have pressed something wrong on my calculator. Okay, which is actually equal to 53.6. Yes, 53.6. And our gamma is equal to cos inverse of that was 501 point. This is 501.85 over 750, and this is coming to and it is negative here. I keep forgetting that negative. So negative 501.85, and this is coming to 132.0 degrees. So these are the answers for the direction, cosines, angles. So you've got your answers for part 2. Thank you.